step-by-step guide to teaching machine learning, ML, starting from the basics to advanced topics. Part 1. Introduction to Machine Learning. Definition of machine learning. Teach the basic concept of ML and how it's a subset of AI. Explain how it enables machines to learn from data. Types of machine learning. Supervised learning, unsupervised learning, reinforcement learning. Applications. Discuss real-world applications like recommendation systems, fraud detection, image recognition, etc. HOPS 2. Prerequisites for machine learning. Mathematics, linear algebra, vectors, matrices, operations on them, dot products, etc. Probability, basics of probability theory, conditional probability, Bayes' theorem. Calculus, differentiation and gradients, statistics, mean, median, mode, variance, probability distributions. Programming, Python, as it's the most common language used in ML. Key libraries, NumPy, Pandas, Matplotlib, scikit-learn. 3. Data preprocessing, data collection, how to collect and import datasets. Data cleaning, handling missing values, dealing with outliers, and cleaning noisy data. Feature scaling, min-max scaling, standardization. Feature engineering, transforming raw data into useful features. Data splitting, splitting the dataset into training and test sets. Taxa 4, supervised learning algorithms. Regression, linear regression, introduce the concept of predicting continuous values. Polynomial regression, extension of linear regression to capture nonlinearity. Classification, logistic regression, binary classification. K-nearest neighbors, KNN, intuitive classification algorithm. Decision trees, explain decision-making structure. Random forest, an ensemble learning method. Support vector machines, effective for high-dimensional spaces. Model evaluation, metrics like accuracy, precision, recall, F1 score, confusion matrix, ROC use. 5. Unsupervised learning algorithms. Clustering, K-means clustering, grouping data points into clusters. Hierarchical clustering, building clusters in a hierarchy. Dimensionality reduction, principal component analysis PCA, reducing the dimensionality of large datasets while retaining important information. Anomaly detection, identifying outliers in data. 6. Model optimization techniques. Cross-validation, K-fold cross-validation to assess model performance. Grid search and random search, hyperparameter tuning techniques. Overfitting and underfitting, causes and how to mitigate them using regularization techniques like lasso and ridge regression. Bias variance trade-off, understanding the balance between model complexity and generalization. 7. Deep learning, introduction to neural networks. Artificial neural networks, ANN, explain the structure of a basic neural network, layers, neurons, weights, and biases. Feed-forward neural networks, how data moves through a neural network. Backpropagation, training neural networks using gradient descent. Activation functions, sigmoid, ReLU, TANT, etc. Deep neural networks, introduction to deeper architectures. 8. Advanced deep learning topics. Convolutional neural networks, CNNs, used for image recognition and processing. Recurrent neural networks, RNNs, handling sequential data, time series, text data. Long short-term memory, LSTM, advanced RNNs for capturing long-term dependencies. Transfer learning, using pre-trained models to fine-tune and solve new tasks. 9. Reinforcement learning. Concept, how agents learn to make decisions by interacting with an environment. Markov decision processes, MDPs, theoretical foundation of reinforcement learning. Q-learning, a basic RL algorithm. Deep Q networks, DQN, combining neural networks with reinforcement learning. 10. Natural language processing, NLP, text processing, tokenization, stemming, lemmatization, bag of words, and TF-IDF, feature extraction from text data. Word embeddings, Word2Vec, Glove. Sequence modeling, using RNNs and LSTMs for NLP tasks like sentiment analysis. Transformers, advanced models like BERT and GPT for state-of-the-art NLP tasks. 11. Model deployment and monitoring, model exporting, saving trained models, e.g. using Pickle. Deployment, how to deploy models using frameworks like Flask or Django. Monitoring and maintenance, monitoring model performance over time, detecting data drift, and retraining. 12. Real-world projects and case studies, recommendation system, building a movie recommendation system using collaborative filtering. Image classification, building a CNN model to classify images. Predictive analytics, predicting house prices or stock trends. Chatbot development, NLP-based chatbot using neural networks. Ethical considerations in machine learning, bias in models, identifying and mitigating bias in datasets. Fairness and transparency, ensuring the ethical use of machine learning. Privacy concerns, handling sensitive data with care and adhering to legal regulations. Each step can be accompanied by exercises and projects to reinforce the concepts. Make sure to break down advanced topics into digestible parts, emphasizing the practical applications and the intuition behind algorithms.